Hi everyone, welcome to the third part of this particular prep series, which is for Walmart Coders 2024. As you know, how we are proceeding, we already have uploaded two videos. If you are starting with this particular video of prep series, what I recommend you is go back to part one and part two, or you can start with this and then after completing this, you can go back there. So in this video also we are going to see a couple of problems from previous year Walmart Coders Hiring Hackathon. Okay. So let us start with the very first problem. So the very first problem here is you are given a list P which contains n numbers. The elements in P are permutation of numbers from 1 to n. Your task is to calculate the number of elements P of I such that I is between 1 and n. I mean, I is greater than 1 and less than n. That satisfy the following condition. P of I is the second smallest number among the three. Okay, P of I minus 1, P of I and P of I plus 1. Okay, so you are given an integer value n, that's the input format, and next line is going to have n integer values which are going to be elements of your permutation, okay, or the array which is given to you. So this problem is I think on very easy side, which was asked in Walmart coders. So problem states like you are given an array of length n, okay, and all the values are between 1 and n. The array itself is permutation of n. So permutation of n in the sense, if n is 4, then its permutations are 1, 2, 3, 4, 4, 3, 1, 2, 3, 1, 2, 4. You understood like what is a permutation, okay? Your array contains all the values from 1 to n and they are arranged in certain order, okay? All the values are unique. So if these criteria are met, we call that array to be permutation. Now what it asks us to do is you have to count how many elements. Suppose if array is I, then how many elements P of I are there such that I is less than n and greater than 1. So you are not considering the first element and the last element. So for all remaining indexes, if this element is second largest out of P of I minus 1, P of I and P of I plus 1. So for every index I, which is in this range, you will consider these three values, P of I minus 1, P of I plus 1, P of I. And if P of I is the second largest value, suppose we have 2, 2, 6. So in this case, obviously, this is the second largest value. Okay. If I have 1, mm, then we have 5, 3. So here, this is going to be the element P of I. So this is not the second largest value. Okay. So this is the largest value. If I have 5, 3, 5 again. So again, this is not the second largest value. This is the smallest one. Okay. So you understood my point. What you have to check is if P of I is the second largest value, then you will increment your count. So this problem is not very hard. There are multiple ways of having this or solving this. One of the very easiest way, because the constraint is very small, n is less than or equal to 50. This is the constraint. So constraint is very small. So what you can do is you can have a loop starting from 1 going till n minus 1. And what you can do is you can take all the three values in an array. So suppose in C++ we have dynamic array like in terms of vector. So suppose in this temporary array I am storing both P of I minus 1, P of I and P of I plus 1. I am doing this. Okay. After this you can sort the values. Sort your temporary array which contains the three values. This is not the most optimal way because of low constraints. We are trying the easiest way. Okay, you will get all the three elements in an array, sort them. Then if the second largest value is same as the value present at index I in original array, then you can increment your count. So that is the whole logic. Okay, so you sort your temporary array. Now you compare. Now second largest value is present at temp of 1. If this value is equal to currently your value at index I in array B, then you will increment your count because this element at index I is the second largest value. So that is the code for it. Okay, pseudo code you can say. So this problem was on the easier end. Okay, so now we will move on to next problem. Or before that, if you want to practice, you can check the link in description. So we are adding link for both the problems. Like you can go there and practice. Try to submit your solution. Okay. Okay. So now moving on to the second problem of this part three of prep series for Walmart Coders 2024. Okay, so let's read down the problem statement. So you are given n boxes of infinite capacity. So there are n boxes and capacity of each box is infinite. And each box initially contains only one ball. The boxes are numbered from 1 to n and also each ball has a color. Okay, initially ball present in box 1 is red and rest all are green. So there are n boxes. Initially, they have one ball. All balls have some color, and box one have red color ball. Rest everyone have green color. You are given Q operation, the ith operation. You need to take out one ball from AI and put it in BI. Okay. So we have multiple operations to perform. In one operation, we take a ball from AI and put it in BI. It is guaranteed that A of I is not empty before this operation. Okay, so there is some ball before we take some one ball out of it. Okay, after processing all the queries, your task is to find the count of boxes that may contain the red ball in the end. Okay, so we actually don't know which ball the person is picking up and transferring to other box. So that's why there can be multiple boxes where red ball can be present after performing queue operations. So we have to print the count of them after processing all the queries. Okay. Number of boxes can be 10 to the power 5. Queries can be 10 to the power 5. And AB is obviously less than equal to N and A is not equal to B. And output is number of boxes. Okay. So let me quickly summarize the problem statement. You are given n boxes. So there are n boxes. Each box have one ball. Each box have one ball. Box one have red ball. Box one have red ball. And all other boxes have green ball. Have green ball. Then you are performing queue operations. In ith operation, you are taking a ball from box A of I and putting it in box B of I. Now, after performing all the operations, you have to count number of boxes where red ball can be present. Where red ball can be present. So many people might get confused while reading the statement. So you might think there is only one ball, how the count is changing. Okay, so think like this. Suppose we'll take one simple example here. We have three boxes, box 1, box 2, and box 3. So initially, these two have green balls. This one have red balls. Okay, suppose you perform an operation. You pick this red ball and add it to box 2. So now after that, there is no red ball in box 1. Box 1 is empty. And your box 2 contains two balls, one is green, other is red. Now after that, you perform two more operations. What are those two operations? One operation is you pick some ball from box 2 and put it in box 1, and you pick some ball from box 2 and put it in ball 3. Now In this case you don't know which ball you're picking, which ball you're putting and all. Okay, so at the end there are chance na you can pick a red ball and put it in box 1. There is a chance also instead of red you pick a green, and similarly for from box 2 to box 3 there is a chance you pick a red ball and put in 3. So here we have equal chances, but one thing is clear. After performing all the three operations, there will be zero balls left in box 2, because from box 2 we have to perform two operations. So both the balls will be out. So we have chances that box 3 might contain red ball. We have chances that box 1 might contain red balls, but there is no chance box 2 contains red balls, because box 2 was having two balls, red and green. One operation it one ball is used in performing operation 1 from picking a ball from box 2 and putting in box 1, and other ball is used for performing the second operation where we use the second ball and put in box 3. So the answer for this these operations is going to be 2. For box 1 and box 3 we have chance that they might contain red ball. Okay, so you don't know, so there can be multiple like chances. You have two chances, na, picking up red or green and all. Okay, so this problem is not very hard. I would say. I would if you ask me about the difficulty of this, I would rate it medium difficulty problem. Okay, the reason is it's based on very small observation, and that is one thing. Okay, so what kind of queries are there? We are given A of I and B of I. It means we are using one ball from A of I, adding it to B of I in box B of I. Okay, so if A of I have a red ball, if A of I have a red ball, and if I pick a ball and transfer it to B of I, then B of I can have a red ball. If as of now B of I is not containing any red ball, B of I can have a red ball. I can say that. Okay. And if after removing this ball, one ball from A of I, if total number of balls of A of I becomes 0, then I can say A of I does not contain any red ball. So these are two observations that we need to deal of. Okay. If there are no balls left after transfer, so obviously box, that particular box or box A of I won't contain any red ball, cannot have any red ball, cannot have any red ball. This is one of the observation. And what is the second observation in this case? The very second observation here is, if A of I contains a red ball, if A of I contains a red ball, and we are transferring one ball from AI to BI, then B of I can contain a red ball after the operation, obviously after the transfer. If earlier B of I was not having any red ball, now after the transfer there are chances I transferred red ball from AI to BI and BI now contains a red ball. So these are the two observations which you need to do in this case. Okay, and based on the observations, one thing you realize is, okay, if there are no balls, so obviously there won't be any red ball. And if You are transferring from a box where red ball is present to a box where red ball is not present, then what can happen is the box in which you are transferring can contain red ball after the transfer. Okay, these observations, based on these observation, one thing we realize or two thing we realize is we need to maintain few things. What? Number of balls in every box. Balls in every box. And what is the second thing? I need to also maintain one array or boolean array which checks if red ball is present in certain box or not. Red ball is present or not. So basically you need to maintain two arrays. One for maintaining the count, how many balls are present in that box, and one for storing a boolean value. You can say if it is true, boolean value is true, it means that ball can contain red ball. Okay, if boolean value is false, it means that box cannot contain any ball. Okay, so now based on these simple observations we can derive up to solutions. Or as I took example earlier, let's have one more example. Suppose I have five boxes. This is box number 1, 2, 3, 4, and 5 is there. Obviously initially every other box than one contains a green ball, box 1 contains a red ball. If I perform this operation, if I transfer a ball from box 2 to 3, so obviously what I ask you to maintain is for every box how many balls are present. Initially that will be 1, 2, 3, 4, 5, 1, 1, 1, 1, 1. Okay, and one more boolean array which will be for does this box contains a red ball or not. So that will be true only for box 1 initially. For all other values, it is going to be 0. 0 means false. You can treat this is for count of balls. And this is a Boolean array, you can say. Boolean array. So this is for red ball. Okay. So now, suppose I performed the operation. I transferred a ball from box 2 to box 3. Now what I am checking here is box 2 or does box 2 contains a red ball? No, it does not contains a red ball. So my box 3 also cannot have any red ball. Okay, I cannot say box 3 can have red ball now. Okay, but I will increment the count. So this count becomes 0. This count becomes 2. Okay. Now suppose next operation is between 1 and 3. So I'm transferring uh, 3 to 1. Let's go like this 3 to 1. So I'm transferring one ball from 3 to 1. So what happens? This becomes 1. Number of balls here. Number of balls in box 1 becomes 2 after the transfer. Okay. Now I perform two operations. First operation is from box 1 I transfer one ball to box 5. Now here what is happening? One ball is going from box 1 to box 5. So count is incrementing. Now I will change this value to 1. Why? Because box 1 can contain red ball. Box 1 can contain red ball, or as of now I can see it is containing red ball, but after the transfer I don't know it will contain or not, but as of now it can contain red ball. So there is a chance I might transfer a red ball to box 5. There is a chance, so I will add this boolean value 1 for box 5. Okay, now suppose next transfer is from box 1 to box 2. Box 1 to box 2. So now number of balls in box 1 is 0. If there is no ball, so obviously there won't be any red ball also in box 1. Okay, but when I was transferring the ball from box 1 to box 2, then at that point, red ball might be present in box 1 and I might have transferred a red ball to box 2. This can happen. So, what will happen here? Count of box 2 will become 1 and it might have a chance that I transferred a red ball. Okay, so after performing all these operations, there are three boxes where red ball can be present. Sorry, two boxes where red ball can be present. It's zero written here, my bad. There are two boxes where red ball can be present. Those are box number 5 and box number 2. So that's the answer in this case. 2 is the answer. Okay. Now, whatever we have discussed till now, we have to write that in terms of code. Okay. So one thing you understood, you can take the input. So I'm not covering the input part. Okay. So here I require an array of length n. What is that array is going to do? Count. So this array of length n plus 1. Why I am taking length n plus 1? Reason being balls are numbered from 1 to n. So obviously if I want n as one of the index, I need to create an array of size n plus 1. This is basic stuff. So you'll have this array of size n plus 1 and every value, index value from 1 onwards represent a box. Okay. So count of every index from 1 to n is going to be equal to 1. Value for those index is going to be 1 because initially every box contains one ball. Okay. Then there is a Boolean array is red of length n plus 1. It is also for index 1, it is true. Means its value is 1. For all other indexes from 2 to n, it is 0. So these indexes are nothing but representing box. Okay. And boxes are numbered from 1 to n. Okay. So this is the story as of now. Now we have to perform operations. How many Q operations are there? So I'll perform Q operations. Now there are two values. First value is going to be box from where I am transferring. This is equal to query I0. So you can assume I have stored my input in a 2D array. Okay, in format like this. 1, 2, 2, 4. So you can assume something like this. So it means like this is the box from where I'm transferring to the other box. Okay. There are multiple queries here. In this case, there are two queries. One query, I'm transferring one ball from box 1 to box 2. And in other query, I'm transferring ball 2 to ball 4. Ball from box 2 to box 4. Okay. So these details are there. I can get B also from here. B is the destination box. So in this is going to be present at queries I1. Okay. Now what is happening? Count of B is increasing by 1 because I am adding one box and count of A is becoming 0. Now I will check if there is red ball present in A box, then obviously red ball can be present in box B also after transfer is red of B is also changed to 1. This is what I'm saying. If red ball is present in box A, then after transfer red ball might be present in box B. Okay. And here I am checking if after transfer count of balls in box A becomes 0. So obviously there cannot be any red ball. Okay. This is what you have to do. So if you are unable to cope up with this, I hope like you understood this part. If you have any doubt, pause the video, rewind it. Okay. Now you already know you just have to go through all the indexes from 1 to n. Okay, and you will check is there any chance this box contains red ball? If the value of this is true, then you will increment your count. Okay, you take a count variable and you will print the count here. That's it. Okay. If I ask you the time complexity is going to be O of Q plus N. So whichever will be the greater value will be your answer. Okay. That's all for this video. Thank you. If you like this content, do share with your friends and don't forget to like and subscribe.